Space is sitting everywhere like a watchdog, like a mechanism which is probably finer than elementary particles, which is doing all this policing, and it has immense energy to correct any anomaly which tries to happen. Tomorrow, if you try to split electron, it will also produce huge amount of energy, more than nuclear energy will. At speed of light, time will become zero, so it will cease to oscillate. All that jiggling of elementary particles, etc. will stop. They say that if you travel faster than light, then time will flow ulta. With whatever technology we have, our perceptions are severely limited. So there are some things which our physics, our space allows us to perceive. There are things which it will not allow us to perceive. So something which is sitting outside our space, maybe watching our space, but sitting outside our space, we can't see that.
Hello everybody, we are back after a long time, and I think it's only the second time since the two of us are together on a podcast. We request you to like, share and subscribe and promote this Technocrat Talks podcast as much as you can. So let's bring us back to the topic of the day. You said you wanted to do a podcast on nothing.
Yes.
And I was wondering, what is so important about this nothing?
Actually, this title of this podcast is something called Nothing. Now, this was a title of a book that I read in high school days. There was a series, in fact, by George Gamow. He was the author who used to simplify science for lay people by explaining complicated concepts very easily in easily digestible ways. And this book dealt with the structure of space and theory of relativity and so many things. Okay, not that what I am talking now is derived from the book, only the title I have liked, so the title is here. Those are small pocket books by George Gamow, and they have contributed a lot to make the science popular in those days. I mean, in India, I can think of Jayant Vishlu Narlikarji. He did a great service to the nation by making science more palatable for people who could be influenced by science, who could be interested in science.
But there are so many people who have written a lot about space or universe and a lot of these theories that are there, Big Bang theory or relativity and so on and so forth. So what's different about this?
Now, most of those literatures, if you see, first of all, they can't do without mathematics. So they will start with some equation, say E is equal to mc square. Now, mass can get converted into energy and vice versa. But how would it happen physically? That part is out. So today we want to discuss about the physical thing, about something which gives an insight of how things could happen. We will try to present the topic in a way that has not been done so far. And we don't want to be lost in theories and terminologies and other jargon which has been there in print media. So we are talking about simple physical concepts to make people appreciate how complicated nothing is. Nothing meaning space.
With all the developments that are there, with all the technological tools that are available to us these days, even with rigor, why would it be difficult to get into it?
With whatever technology we have, our perceptions are severely limited. So there are some things which our physics, our space allows us to perceive. There are things which it will not allow us to perceive. So something which is sitting outside our space, maybe watching our space, but sitting outside our space, we can't see that. We can only see what our space permits us to see.
Now, to get into it, what kind of structure is required to carry out this kind of disciplined monitoring that the space probably does of things that happen within the universe? What kind of discipline would be required at the subatomic and atomic levels?
Electron will always have same charge and same mass and same charge to mass ratio. So also with proton, it will have only certain mass. Neutron has certain mass. The elements can come from anywhere in the space, yet they will have the same spectrum. They will have the same Fraunhofer lines and all those. The thing is, now if you imagine that, who stops you from, say, doubling the mass of an electron? Suppose you take an electron and just double the mass. Now, mass is something else, charge is something else. So you can have certain charge, you can have certain mass.
Yeah.
Okay. So I have a particle with some mass, I put some charge on it, and that becomes a particle with charge, say electron.
Hmm.
But if I try to change the charge on electron, or I try to change the mass of electron, the space doesn't like it. It does not allow. It will immediately split that again. Certain elements are stable, certain elements are not stable. You try to make some nucleus with the unauthorized charge to mass ratio, with unauthorized mass distribution, the space will split it. Space doesn't allow it to exist. All the radioisotopes which are unstable, they are unstable because space is not allowing them to exist. So space is sitting everywhere like a watchdog, like a mechanism which is probably finer than elementary particles, which is doing all this policing, and it has immense energy to correct any anomaly which tries to happen. So nuclear energy is great because space is putting that great energy. Tomorrow, if you try to split electron, it will also produce huge amount of energy, probably more than nuclear energy also. Space is anything but a passive void. It is having a well-defined structure. It is able to do monitoring, all-pervasive monitoring. Yeah. So it has to be a wonderful system.
So we've understood some part of behavior of the space.
Yeah.
What it allows, what it doesn't, and we are making use of that behavior or behavioral anomalies. But so far, we haven't been able to figure out how to alter that behavior of space, or have we in any such experiments?
No. See, we say our space follows our rules in which we are existing. If we have to bypass our physics, we have to go to some other space which has a different physics. But we can't go out of our space.
This limitation of perception, like what can we perceive and what can we not perceive? How do we know?
See, we can perceive mostly through electromagnetic waves. X-ray, gamma rays, light, infrared, ultraviolet, everything is electromagnetic waves. Now, for electromagnetic waves to propagate, in the space you have to have some media which carries electromagnetic wave. We say that electromagnetic waves are transverse vibrations, something like vibrations of string. Okay. So you imagine that space could be made up of strings which carry some charges at some distances, at some pitch. There is a discreteness in space. So there is a string with charges at equal pitch, it oscillates and it propagates electromagnetic waves, and those charges have zero mass. So once they have zero mass, they cannot exert any force until they sit on some mass. But they can do repulsion and attraction, they can do all that electrostatic thing. It will not be a force, but they can carry the disturbance. Yeah. So that is what we termed as ether once, that ether is required to conduct the light and electromagnetic. So the space carries those superstrings that are supposed to carry the light. Now we are seeing through light. I remember an experiment which we did in high school days, that to prove that light travels in a straight line, we had a candle, we had 3 cardboards with holes in the middle, we kept them on a table, and we viewed when the 3 holes were aligned in a straight line, then only then we were able to see the light. And the proof that we established that with that was that light travels in straight line. But now I put the question in other way, what is straight line? Straight line is the path of light. So whatever we say, straight line will be the path with which the light will take to travel. Okay. Now light is traveling through superstring. So suppose the superstring that is carrying light goes around in a curved path. Until I go outside my space, I can't see that curved path. I will only see it as straight line. So because I am seeing through light, the way the light is traveling, that I am seeing a straight line. So within the space, what else is there where the light is not reaching? I can never know. That is the limit of my perception, our perception. Because no electromagnetic wave will go in that region. it will only travel through those strings. So, however, those strings are disposed in the absolute space. Let us now say that there is something called as absolute space, which is really the void. And then there is our space, and our space is carrying all those superstrings. The light is traveling only through that, so we are able to only perceive things which are lying in this. So, there can be multiple spaces. Parallel to our space, there can be another space, but our light is not entering there, their light is not coming here.
So what if the space-time continuum is kind of bent or something? So would the perception change?
Now, if it is bent, we can't make out that it is bent. It surely could be bent in absolute space. But unless we step out of our space, we can't say that it is bent or not. We can't predict anything on that. Whatever scientific things we may do, whatever advanced technology we may do, we are still restricted by our senses, electromagnetic waves, and we are not able to break out of our space.
So we spoke of waves. Now let's talk about matter. What is it?
We say that mass is the amount of matter in something. Now, mass is, to me, a specialized zone in our space where there are some special properties, like properties of momentum, like property of gravitation, like property of gyrostability. There are some few properties which we attribute to bodies having mass, and something which has a mass only can apply a force. So, mass is something which is anchoring you in the space. Otherwise, you would float. And it's like, suppose you are standing in a boat in a lake, okay, and you want to pull another boat towards you. How could you do? So, you have to put a rope. There are two boats now on a lake, and you have a rope in the middle, and there are two persons on either boat, and you are trying to shorten the intervening length of rope so that the boats will come closer. Now, which boat will move less, which boat will move more when they are going to each other? That depends on mass of boat A, mass of boat B. Yeah. So, they can meet at middle point, they may not meet at middle point, they will meet anywhere. So, similarly, the masses are disposed in space. If masses were not there, everything would be floating. If masses are there, you can apply some force. But mass is something which is anchoring you in space. It is giving you some anchorage in space. That is how you are able to pull something towards you or push something away from you. Force can only be applied when you are sitting on a mass. So, charge which is having zero mass cannot apply any force. Only when it sits on some mass can it apply a push or a pull on something else. So, mass is that property. Normally, we say in physics that mass, length and time are the primary quantities. But actually, mass, there is nothing to suggest that mass is a primary quantity. Actually, it is a secondary quantity. Momentum is more primary.
Why do you say so?
Because momentum is something which you can readily perceive. Momentum of some body is what you can measure. Mass you can't measure. Mass how it. So, actually, you will calculate mass through momentum or through gravitation. Okay. Directly you can't measure mass. Because it's inertial mass or gravitational mass. There are two masses. Again, and there is slight discrepancy between them. So, mass is a calculated quantity from something which is more primary observation when you do in space. So, momentum is more primary.
So, glad you brought in length, mass and time. So, length, matter and time. So, let's talk about time. What is its relationship with space?
See, as far as the sense of time is concerned, how do we sense time? By oscillation of a quartz crystal in a clock, or oscillation of a pendulum, or vibration in some molecules. So, basically anything which is periodic, which is ticking periodically, we measure or we perceive time in terms of that, how many times it has ticked. Now, all these mechanisms will happen at molecular level, some of them can happen at atomic level, some may even happen at elementary particle level. Okay, fine. So, basically any kind of oscillations are periodic. So, that involves jiggling of some charges, that involves moving of some electrons in orbit. So all these are the things which are giving rise to something periodic. Okay. Now, as far as our mind is concerned, all our thoughts are chemical reactions in neurons, ionic currents, which happen at molecular level. So obviously they are influenced by electromagnetics of elementary particles and so many things. So whatever space does to elementary particles will influence anything happening here also. Now, if you say that space does something and these oscillations become slower, theory of relativity says that it will happen. Time will run slowly when you are moving.
At certain speed or just?
At speed of light, time will become 0.
Yeah.
So it will cease to oscillate. If you are moving at speed of light, then time will not tick for you.
Yeah.
Because with respect to the structure of space,
Yep.
all that jiggling of elementary particles, etc., will stop. It will freeze wherever it is. So the time will not progress. So you cannot perceive time. Nothing which is oscillating, ticking, etc., will happen. So it will stay where it is. And to extrapolate it further, they say that if you travel faster than light, then time will flow ulta. Then all the oscillations will go in reverse. And then probably your sense of time will start going back. All the electrons will start reversing their orbit. So wherever they were earlier, they will come back there. So whatever happened few milliseconds, few femtoseconds back will happen again. Yeah. So that is the concept of time machine, if you please. That how you move in relation with space structure determines how time will flow, whether it will flow faster or it will flow slower, or it will go in reverse, or what way.
So, thought experiment. So, this space A, this space B, they're not identical. So, the way time would function and the if let's say we were to measure time, but just by measuring certain vibrations in certain molecules or some subatomic particles, if the rate at which they vibrate is different in both spaces, then the length of time in both spaces would be different.
Would be different. Now, of course, many things would be different. The physics and chemistry would be different. So you don't know if interactions will be similar or they will be totally different. If it has a different periodic table, if it has a different chemistry, if it has a different physics, probably all the interactions, the rules of electricity, magnetism will also be different probably. So there is nothing in common, I mean, where you are able to connect the two worlds.
And our primary thing is that our space is controlling the way time or we perceive time in this particular space.
That's right.
And there's no way to alter that.
There's no way to alter. Of course, time machine concept has been there, but I have said in some of my earlier biology video also that it is a flawed concept. Because imagine that there is a time machine and you sit into it and you are able to go back in time. Okay. Now, first of all, who should travel in time? Somebody who's sitting in the machine or who's outside? Now, obviously, common sense says that somebody who's sitting in the machine should travel. Because he will be moving faster than light, etc. if the machine moves. Right. So, what happens if he starts going back in time? If he starts, see, it will not suddenly jump by 1000 years. And you can't suddenly go to Badshah Akbar's time or even older times.
He'll come out
Mahabharata
of the machine
times.
first.
Yeah. It will go by few milliseconds, few seconds. When that happens, he will come out of time machine. And then the game will stop. You can't go any further. And if it goes forward in time, then anyway you die soon. So, for that reason, time machine has not happened and it will not happen. You can be rest assured. It will not happen. Because the concept is flawed. The idea itself is flawed.
So, let's get to a philosophical question. I mean, if space is the all-controlling thing, if it controls everything, then is there such a thing as free will?
Free will is here. It's in the thought, it's in the personality. Now, all those things are above molecular level. All those things are above molecular level. As I said earlier, we normally say that me and space. You are not outside space, you are a part of space. Your brain is very much in space, it is a part of space. So as much as it will influence everything else, it will influence here also, obviously. So whatever you can think anytime is already influenced by space. So you are thinking like that because space has told you to think like that. It has conjured up things so that you will think like that. So whatever you are, whatever is your personality, whatever is your thought process, everything is already influenced by Brahman. Everything is already influenced by Brahman. You can't be outside the Brahman.
Right. So
you are a part of Brahman, isn't it?
Is it possible physically for one's thought to influence someone else's thought, or one mass to influence someone else's thought?
That can happen. That happens. That is permitted by space. But that is again as permitted by space. Hey, whenever somebody is thinking and deep thinking, then you emit lot of brain waves, alpha, beta, gamma, delta. Those are the brain waves, different frequencies, different amplitude. So alpha waves make somebody to go in deep trance. You can go in deep thought, meditative kind of thing. So people, when they meditate, they emit more alpha, and somebody who receives that alpha can also automatically go in deep thoughts. So yes, there is a mutual interaction permitted. The space does permit sharing of your intelligence with other, sharing of your thought with other. That is allowed. So that is as allowed by space.
And what does it not allow?
We don't know. Whatever it doesn't allow will not happen, but you don't come to know. You come to see only what happens in your space. So our perceptions are only restricted to what is allowed by the space and what we are able to see.
All right. So I think this has been an enlightening conversation on nothing. So hopefully we'll carry something from this conversation. And
but that nothing happens to be everything.
well, yes. So hopefully everything is called nothing, and we'll learn more about everything or nothing. So thanks a lot for this conversation, and we'll continue to meet again and have more deeper conversations. Well, thank you for watching. We request you to like, share, and subscribe, and promote this Technocrat Talks podcast as much as you can. Bye-bye.
Bye-bye.
It's only the second time since the two of us are together on a podcast. This is a long time coming. What has been keeping you busy?
See, when we started this idea of Technocrat Talks, basically what I had in mind were three different series. In between, we tried to start some interviews on the technical side, on Industry 4, Industry 5, etc. The thing is that I'm always more passionate about talking things where I can represent something original. I mean, I don't like to just compile things and report something which others are already doing, other podcasts are already discussing. We don't want to do that. We want to do in Technocrat Talk something what others are not doing. Now, this topic of today, this is about simplifying theory of relativity and simplifying complex things in physics for a lay person without having to go in too much of differential equations and mathematics, and because that is something which scares off people. And one big minus with being mathematical is that mathematicians lose touch with the physical side. So mathematician may not know really what he is talking about. They will just blindly extrapolate some formulae and then come out with some strange conclusions, as it happened in theory of relativity. But physically, how it would happen, how it could get executed by nature, now that part takes a back seat. Now I am more interested, I have been always more interested in this other part, the physical part. How does it happen physically?
But tell me one thing, like when you read books, and especially these kind of books, they are heavily loaded with formulae, they are heavily loaded with jargon. What helps in pulling back and taking a helicopter view of things, and then actually also philosophically as well as physically creating sense of making sense of things that are there in these books?
There are two schools of thought which are going on in industries nowadays. Now one category is teachers. Now it is teacher's job to make difficult things look very easy. So I belong to temperamentally being a teacher. But there is other group which is consultant group. Now they do the reverse way thing. Very easy thing, they make it to look very difficult by throwing in Japanese jargon and you know what. Very simple common sense thing, they will make it to look as if they are very difficult. And what happens when too much of mathematics happens, as it happened in engineering curricula, that subjects are very easy, but they are made to look formidable when they throw in a lot of mathematics in it. It becomes very challenging to understand, it becomes challenging to remember, to relate with the physical world. So I always want to moderate, and I always, I mean, I'm not saying that mathematics should not be done. Of course, it should be done for the rigor. But then for the lay people, to give them concepts, we have to be able to explain in very simple terminology without having to take resort to mathematical equations and formulae and you know